Okay, students, I'm going to lecture for just a few minutes. And the first thing I want to do is, we're recording this and I'll YouTube it after class. The first thing I want to do is mention that there's a few people that are absent and there's been a few drops that I know of. And so if you have a friend that needs to get into this section, I'm sure the waiting list is running, but anyways, you might want to alert them and maybe they can scamper in for Friday's class. All right, we're going to talk about the storm coming, and then we're going to do some demonstrations up here with wave phenomena, and then we'll finish reviewing the syllabus. By the way, where did we stop with the syllabus last time? Grading? Okay. All right. And then I'll give you a homework assignment, reading assignment. And just to remind you, there's no classes on Monday anyway. The hurricane, God forbid, will not, be on top of us on Monday, but we have the day off anyway. So now, hey, who was here 2 years ago when they had UCF closed off for like almost 2 weeks? You slackers! Well, everybody's smiling at that. What the? Nika, what is this world coming to? Any, anyway, all right, all right, all right. Shh, shh, shh. I was actually kind of happy too, so I'm a slacker as far as that goes. But I doubt, for reasons that we're going to go into in a few minutes, over the next few minutes, I have reason to doubt that we're going to lose any school time. So, but let's take a look at Tropical Storm Dorian. And this is just by way of giving you a few tips from me as a physicist. Now, nobody in here is a physicist, not yet anyways. But I know a lot about not climate or hurricane modeling, but numerical modeling of physical systems. And I want to tell you about some of the results of that. Now, here's the track from last night. And there's been a lot of change. No, this is 8 o'clock this morning. And there's been a lot of changes overnight. Last night it was forecast to hit down in somewhere in Brevard County, like Melbourne or so, if you look at the cone. And it's still way out in the outer cone, but this morning it looks like it's going to hit up in Volusia County. All right. If you look at this carefully on the screen, you'll see that. And I'm sure you guys know how to look at all these images and stuff. But that's a shift of about 80 miles. So here's the shift. So I just went from Melbourne up to Daytona Beach, and it's about 80 miles as a crow flies. And that's overnight. That's one 12-hour. Now, this is the outer days of their ability to project. If you look at these tracks, let's look at the tracks now. Here are the tracks, or the projected tracks of the different models. And you can see down where TS is, that's where it is as of, I think, 10 o'clock last night. And it's heading into the Virgin Islands, where I used to teach. And notice that the tracks are all right on top of each other. But then up here, as it gets closer to Florida, they start to diverge. And my wonderful students, that is typical of numerical systems where you can't use a good, straight, precise F equals MA type calculation. Like and here's something I talked about in 2053, and maybe that didn't have me, your instructors did as well. A rocket taken off from Kennedy Space Center. That's difficult to model, but they do a pretty good job on rockets and stuff. But it's difficult for us to model it because it's a system in which the mass is changing significantly. For every second of liftoff, you're losing huge tons of rocket fuel at the back end of that machine. And that's what pushes you upward, but it also makes the overall vehicle that's being pushed upward lighter, and therefore it accelerates. And the acceleration is changing. So F equals ma is really tricky with that. But we have a fairly good handle on those babies. It just takes a lot of computers. Same thing with this, but this is not an object. This is it's a system of thermally convecting fluids, multiple fluids. The fluid that we know as the atmosphere and the fluid that we know as the Atlantic and the Caribbean. All right. The thermal energy that that builds the storm comes from the sea. And so you look at the sea surface temperatures. Did you know that a hurricane and in a tropical storm will leave behind a path of cooler water? They can measure it, you know, from the satellites in space. You know, it's not a huge difference, but it's enough that they can see it. So it's like cool track where the hurricane passed. And that shows you the amount of energy that it extracted from the ocean. Now, that's a very difficult system. And that's why these things, after the first 2-3 days, they're pretty much worthless. Well, they're not worthless, but they're shaky. I'll just put it this way. And that's that big gap there between the white model and the yellow model. All right. And that is so the things that I model are like black holes and boson stars in curved spacetime. And it's actually easier to do that than it is to do these things. The fluid dynamics is about the toughest thing in physics. And they got a whole lot of PhDs down there in Miami running those computers. And it's tough. It's very tough. Now, the best model, as far as I can tell, is the yellow one. That's the GFS model. And there's a couple things about this that I want to point out. Notice, if you look at that carefully, the yellow, that's the one that starts heading for South Carolina in the outer days there. It doesn't turn as radically as the other models. And what I have found, I studied Hurricane Matthew and Hurricane Irma very carefully. I studied the tracks versus the forecast. So they forecast it, and then 2-3 days later, you can compare the actual track to where it was forecast to be. And what I found is in line with what always happens with these numerical models, and that is the physical system does things that the model can't adapt to. Because you know the physical system knows what it's doing. I mean, it's just a big self-organized convective storm, huge, like a tornado or a sun devil or something like that. Or I should say a dust devil. But our computers can't compete with, you know, think about that. In this room, you know, Avogadro's number, everybody's heard of that, right? 6.02 times 10 to the 23, right? So that's for a few grams of air, right? And think of all the air in this room. Okay, now multiply that many grams by Avogadro's number. Now think of all the grams of air in a hurricane system and multiply that by Avogadro's number. And that's how many F equal MAs you got to be able to handle to get a lockdown. And so that's why this thing's got wobbles in it, and it doesn't turn as, you know, it's like if you were modeling a Camaro, a Bumblebee Camaro, and your model, so I love Bumblebee, you know, but although I saw a guy coming into campus today in a GT, a Mustang GT, and those babies are hot too. So I was gonna give you an IQ test today on clickers. By the way, did you bring your clickers? All right, we'll do a little clicking in here in a minute. I was gonna give you an IQ test. You know, which is tougher, which is better, the Mustang GT or Bumblebee Camaro. And you know what? I'd have to say, I couldn't, I'd have to really think to make up my mind on that. Anyway, so the problem with a thermal system known as a hurricane, you got Avogadro's, it's almost like Avogadro's number squared of particles, oxygens and nitrogens. And then so that's a lot of F equals ma and momentum and kinetic energy. You got to try to figure out all that if you want to make it exact. Plus, it obeys the heat equation, the heat transport equations, and that's very tough. So that's another. So the number of equations that you have to model is ginormous, and so it's like, so the reaction of your program, your numerical modeling program, is like taking a Bumblebee Camaro, and your model of the Camaro says you could take a 24-meter radius of curvature turn at 87 miles per hour, and yet Bumblebee can actually take it at 92 miles an hour. All right? And your model can't tell you exactly where it's going to be because it can't make an exact model of Bumblebee. Now, Bumblebee's a rigid machine, fairly rigid, so their models are probably pretty good if they make them. But for this, the models, there's a lot of, in physics, we have this very precise term for this kind of deviation between what the system does and what the model does. And the term that we have is slop, S-L-O-P. There's a lot of slop in the solution, and you can't avoid it, especially in the longer you run your program. So for a couple, 3 days, you're not too bad. Everything's tight. But then 3-4 days out, that starts to spread out. And that's why in overnight, we got that 80-mile shift. And that was just from whatever model the hurricane center was using. So my advice to you is, from studying Matthew and Irma and studying the models, what you want to keep track of, and keep your eye on the turns. And this track has got a couple turns. It's got a right turn north of Puerto Rico, and then a left turn as it comes into the Bahamas. But what the storm does might not match up to what any of the models do. All right, the storm might turn a little bit sharp. All right, so the white model is putting the storm down there in I don't know, Palm Beach or Fort Lauderdale somewhere, right? And the GFS, that's the yellowish one, that's putting it up in South Carolina, right? So we still got, but by Friday we should have a better idea where it's going to come ashore. So that thing could change, and where it's going to change, we're going to see the shifts is in the turns. So that's my comments to you on the storm, and probably we'll talk more about it on Friday. Let's do some demonstrations up here. I'm going to pause the podcast or pause the YouTube for a second. All right, a couple extra notes. Hydrogen. You've looked at the quantum fingerprints of hydrogen, and in the universe at large, the visible universe, we figure about 75% of the visible universe is hydrogen. Helium. We can also see its quantum fingerprints when we look at stars and galaxies. 24% of the visible universe, approximately. Now, for those of you that are heading to medical school, that's not very important knowledge. Medical school and everything else is the other 1%. Iron, oxygen, carbon, nickel, all the other elements. So the top two things on the periodic table That's like 99% of the visible universe. Everything else is like 1%. But here on our planet, we've got a lot of that other 1% of the elements stuff, and that's where human life, all life is you know, on the move. So it's interesting to know. Now, the reason that we did these two demonstrations, the diffraction grade, we're going to learn about diffraction. We're going to learn about this diffraction grading and how it allows you to disperse light. Go ahead and write that word down, dispersion. A diffraction grating, which is what we have, will disperse light into its spectrum. In the case of hydrogen, helium, and neon, if it's pure, you only get a few colors. Well, neon, you get quite a bit, but still you don't get the full rainbow. For an incandescent light source or a projector, you get a full continuous spectrum, a rainbow. All right, that's a different kind of a spectrum. The diffraction grating that you used is a little piece of plastic with teeny tiny lines basically photocopied onto it. And the light goes through the open areas, and then the lines, they're just little black lines. They're very thin. And in fact, it says, mine says, what does it say here? So many per millimeter. 500 lines per millimeter. So that's really small per millimeter. So it's blocked by the lines, and it goes between the lines through the and going through those gaps forms the discrete spectrum. So colors go certain directions. You know, the red goes one direction, and then the kind of aqua hydrogen line, that's the red is known as H alpha, hydrogen alpha. The aqua bluish one is called H beta. The two purpley lines, if you saw them, are H gamma and H delta. Now they go specific directions depending on the wavelength. Now we're going to work on all that stuff this semester. Toward the end of the semester, when we talk about physical optics, wave optics, that's one of the later chapters. The reason that's important for us is because the energy levels of hydrogen atoms, helium atoms, neon atoms are revealed by the color and wavelength and frequency of the spectral lines that you just saw. Now, how that works, believe it or not, the fact that there are only specific colors and you don't get all the colors of the rainbow, that means that the electrons live at certain elevations above the nucleus and no other. The orbits are quantized. You know, so there's an orbit, so the electron has an orbit here, and then nothing until it gets out to here, and then the third energy level, the second excited state. Oh, did I say second excited state? Yeah, that's a little further out, and nothing in between. So there's a ground state or the fundamental, and then the first harmonic or the first excited state, and the second excited state. And those energy levels, you know what they're controlled by? Standing waves. The first demonstration that we did. Because as I'll tell you at the end of the semester, electrons behave as waves. We now know. Nobody knew what these spectra, nobody knew why spectra were discrete like that. You know, they measured it back in the 1800s. You know, the spectrum of the sun, they saw, you know, different spectral lines and stuff, but nobody knew why. And finally, about 100 years ago, they figured out why. The quantum theory of hydrogen and the quantum theory of atoms. And I'll be teaching you a little bit about that by the end of the semester. Okay, hopefully by by December, we'll have dipped a little bit into that and you'll have just a taste of it. And for those of you that are heading for med school, those energy levels also apply to stuff like MRI, magnetic resonance. Oh, resonance? Did I say resonance? Yeah, waves. Yeah, it's all waves. So all the stuff, we're putting it all together this semester. So by the end of the semester, you're going to have a good idea on how medicines work. Because molecules have energy levels as well. They might be in the infrared. You can't see those. You might have some, and definitely some atoms have ultraviolet spectral lines, but we can observe them with ultraviolet detectors, infrared detectors. So we got them, even though our eyeballs can't see everything. But all your medicines, all your ionic bonding, your covalent bond, you know what else? The standing waves. You know what covalent bonding is? Two standing waves talking to each other and, trying to cooperate. So that's what covalent bonding is. It's cool. Cool, cool, cool. All right, now let's get out. We got a scientific question coming up with the iClickers. So get your iClicker turned on. And let me, and then when you got your whole tables worth, just bring them on up. Oh, you get it. You give that to Andrew.
You said the frequency is on A?
The frequency.
So I had it on D last semester with you.
Yeah, let me see what the settings are. Oh, we're still on frequency AA. We'll just use AA this semester, I guess. Does anybody still have diffraction gratings? Okay, good. Let's go to the laptop. Yeah. 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 All right. If you don't know how to operate an iClicker, or you haven't done this for a while, if your frequency is not AA, you should get a message that says Go Nitro if you're on there. So what you do is, if you didn't get that, hold the power button until a little box starts flashing, and then AA. Okay, now see that? You get the
checkmark and then the
Go Nitro. Oh, it just says ready. Anyways, so if you're on frequency AA, you're good. It was supposed to say that. I don't know why it's not, but okay, if it just says ready, you're good. All right. Now, as promised, I have another highly scientific question. And I just want to say it's been nice knowing you, because this one's tough. I guarantee I'm going to mentally defeat many of you with this Chuck Norris question. Okay, 15 seconds to vote. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, now if you got a check mark, that means I got your answer. And hopefully you guys, now I'm going to check the answers here. Oh my goodness. A bunch of people voted for boop, Barney and Justin Bieber. What? I'm not. I'm not. And most of you voted for Chuck Norris. Yeah. But the thing, You know, and just to let you know, I know everybody that voted for Barney. As soon as you register your clicker, I'll know. Anyways, so most of you did vote for Chuck Norris, but of course that's not the right answer. No, it's Bruce Lee. And Bruce Lee is the only known human to have defeated Chuck Norris in a movie back in 1972. And I'll tell you what else. I was reading about this movie. I think it was in IMDb about this movie, and Chuck Norris said Bruce Lee was way tougher than him, very tough. So that's good to know. Anyways, now let's get back to the syllabus. And we talked about a bunch of stuff last time. Attendance, we did talk about this. What we will be doing, let's just review that. Students will be working in groups. Each group consists of 3 students. Students are expected to interact with their team members, i.e. talk, and participate. And actually, you know what else? Probably sketch and make diagrams. I'll be emphasizing that a lot. Participate actively in in all class activities, which you guys are doing pretty good so far. They consist of experiments, discussions, short student presentations, like doing a problem like these guys, they did a problem at the board. We'll probably do some of that this semester. Groups will be rotated during this semester. We talked about this, I think. Class information and notes will be posted in web courses and YouTube. Study sets will be provided, practice problems with detailed solutions. For assigning the grade for in-class work, your in-class work will be reviewed and your participation will be observed. So what I'm going to be doing is going around with my attendance list and just kind of memorizing names and faces as I go through around class. And I'll probably give one to these to Kendra and also to Andrew so they can use it. Okay, next page. If you miss an exam due to absence, either excused or unexcused, that's effectively a 0 and will be the exam score that is dropped. Remember, we keep the best 2 out of 3 midterms. And most of you, like 80% or more, will be here for all 3, so it's not a big deal. The other 2 exams you do take will be your best 2 scores because they're your only 2 scores. I do not give makeup exams, neither late nor early, only the exams on this schedule. All right, so the exams will be in here, and you just got to be here on time. Final exam is cumulative, mandatory, and cannot be dropped, and unfortunately it's at 7 o'clock. Remember, down the bottom, cross out 7:30 and put in 7 on your sheet. Make sure your schedule is clear on Friday, December 6th until lunchtime or so. So if you have tickets for it goes until 9:50. So if you have tickets for 10:15 at the airport, you ain't gonna make it. I guarantee it. All right. So make sure you don't have to be to the airport until after lunch or so, because you got to check in early and all that stuff for TSA. Do not schedule airline tickets, cruises, or work at your off-campus job until well after 12 noon. I have priority on your time until 9:50, and I never budge. Make perfect attendance at exams your objective. All right. Now the grade scale. There's no plus or minus, just straight letter grades. A, B, C, D, and F. 240 total points, and from 2 midterms, 1 final, classwork and coursework. And I'll go over the point values for each of those in a minute. So 216 points or more, that's an A. That's 90% of all the possible points that you can get. 180, that's 75%. 144, that's for a C, 60%. D is 50% of the pointage. F is below 50%. And most of you guys are gonna have somewhere C, B, or A. And you know what? I never curve. I don't grade on the curve. Okay, it says that right above the grade scale. And what that means is, if I graded on a curve, that means only a few of you would be able to have A's. A set number would be able to have A's, and a set number for B's, and a set number for C's, D's, and F's. So what that means is, if you're a really good student, I might not be able to give you an A. But the way that I do things, you accumulate points, you start crushing things at the end of the semester, as some of you will start to do, and I never know who it's going to be, but I always know somebody's going to start crushing things. At least, a handful of yous, and maybe for the first time in a science class. But you'll get the A. I mean, if you earn it, you get it. I don't curve. It's a ripoff. And it's also an excuse for lazy faculty to just give you willy-nilly any test they feel like giving you, and then say, oh well, I'll just curve it. And it's foolishness in my opinion. It's laziness. Okay, exam schedule. We already went over this. September 18th, October 16th, November 13th, basically a month apart. And then December 6th, 7 in the morning. So remember, no early exams, no late exams, no makeup exams, only these exams. All right. And the final exam is not droppable. You just got to be here. So if you feel, most of you guys are serious students, so that's good. So, but if you're feeling like slacking off and not taking the exam, get your what in here. Even if we have to, if you have to come in, somebody wheels you in a wheelchair from the emergency room, or if they have to take away the roof tiles and lower you down by ropes from a helicopter, get yourself in here. All right. You'll definitely be happy about it. All right. Cheating. Any cheating I detect on exams will be punishable by no less than a 0 on the examination. In question and lowering the semester grade, possibly, and up to expulsion. And we have done that for this class, in fact, in other semesters. And I mean, not for you guys, but for 2054. Operating another student's iClicker is also cheating, so don't be doing that. Okay, accommodations. I believe I already read this. UCF is committed to providing reasonable accommodations for all persons with disabilities. I share the same commitment. Students with disabilities who need accommodations must be registered with Student Accessibility Services, SAS, which is across the way here at Farrell Commons, room 185. And the phone number's here on the paper. You have to do that before requesting accommodations from me. Students registered with SAS that need accommodations must initiate contact through SAS and Knights Access. There's the website for their SAS website. No accommodations will be provided until the student has used SAS Knights Access to request accommodations. So what that means is, if that applies to you, what it means is you have to, first of all, fill out your initial paperwork with SAS, and I've gotten a few of those already. And also, for each exam, you have to request the exam to be taken at SAS or whatever your accommodation is. So we do that every semester, so it's not a problem, but you just got to get your paperwork going. Okay, federal surveillance attendance. What they're looking for in the attendance quiz is clicks. And the sysadmin, one of my friends is a system administrator, and he said, yeah, all they do, they just run this ginormous program. They check everybody's web courses area for every class to see if there's any clicks. Okay. And then they know that you're engaged with the stuff for the semester, and then they pay you your dineros. Apparently, there's a lot of fraud with student loans and financial aid. And I have read about some of it from other colleges, but that's why they're doing it, to try to prevent fraud. Anyway, so do that. And I know some of you have already done homework 0. That's going to be our thing. Mandatory exam attendance. Okay, that's the next thing here. At UCF, academics comes first. Attendance at exams is mandatory. University excused absences are only for religious observances. So, like for us, that would be Yom Kippur or something, or some other religious observance. Intercollegiate athletics and activities, military call-ups, and university verified family or medical emergencies. Weddings, plane tickets that your parents got at Priceline.com, etc., are not legitimate excuses. So that's like, so the university verified family or medical emergency. So we, every semester have maybe 1 or 2 students with family medical emergency. But we'll verify that, and then you'll have an excused absence. But the thing is, it doesn't mean that still will be your dropped exam. If you have more than one excused absence, then we maybe reconfigure your grade or something. But if all you do is miss one, excused or not, then that's going to be your dropped exam. So, by the way, if the other, down here at the bottom of the page, it says this syllabus is subject to change as needed per instructor. So what that means is if there's a hurricane that blows away exam 1 on our schedule, hopefully that won't happen. But it has happened in the past, so we'll change things around. But other than that, you know, it is physics department policy that making up missed work will only be permitted for university sanctioned activities and bona fide medical or family reasons. Authentic justifying documentation must be provided in every case and in advance for university sanctioned activities. Now, for those of you that may be on an athletic team or a debate team or a club or something like that, your advisor or your coach will give you something called a program verification form. And then you get that to me. And that will be the official notice of, your travel dates and all that kind of stuff. At the discretion of the instructor, the makeup may take any reasonable and appropriate form, including but not limited to the following: a replacement exam, replacing the missed work with the same score as a later exam, or allowing a dropped exam. Now that last clause, allowing a dropped exam, I want you to underline that. All right, because that's what we do. All right, this paragraph, these 2 paragraphs are the same for every physics department syllabus. So, all right, one more thing I want to mention about this. Um, you know, uh, this is going back several years now, 5, 6 years maybe. I had a student that told me her mother died or her grandmother died toward the end of the semester, couldn't make the final. I said, all right, I need some kind of documentation. And it happens, but I still have to ask for documentation. And it's rough. And I hope it doesn't happen for anybody in here. But, getting a death notice or certificate of death is not a lot of fun. And so sometimes I say, well, how about a funeral notice from the newspaper? From the funeral home. And so what the student did was send me an invitation to the funeral. I could get you the invitation. Would that be? I said, all right, I'll take a look at it. So the student sent me this, an envelope about, this big, right, white, really nice. And inside was a card, it folds out and it says you're invited to the funeral of Jane Doe, her grandmother, such and such time at, Brand X funeral home. And I thought, okay, well, I guess this is kind of documentation, but I still have to check it out. And so I was looking at it, And a student in my other class saw it and said, "Oh, that's a wedding invitation, Dr. B." I said, "What?" "Oh yeah, I have software that is just like that." You know, she's getting married or something, or fixing to get married or something. And so, and I'd never seen anybody give an invitation, like that to a funeral. Weddings, engagement parties, baby shower, all that stuff, yeah, but never for a funeral. So so you guys are smiling now. So I'll tell you the rest of the story. So I decided she gave me the name of the funeral home. That's in the announcement, right? So I called it. I don't know. It was up in Georgia or something, or Florida, North Florida, somewhere north here. So I called them up and I said, I'm just checking to verify, the funeral date, etc. of Jane. I mentioned the name of the deceased, and the funeral director said, "Well, she's not dead. In fact, she works here."
Oh my god.
Z. No, I don't think they had Z on the transcript back then. Maybe they did. But yeah, she went through the system and reported for academic misconduct. So, so I check stuff out, you know, but a lot of, huh?
I have my study hours when I'm
Yeah, no, we'll do that in a minute. Okay, so that's by way of telling you about documentation. And just so you know, if um, if you have, I know students have serious health issues sometimes. I mean, serious health issues, and you're gonna miss classes. You're doing dialysis or something. And I try to, you know, but well, you have to document it, and then we'll try to work out a plan. And here's another thing. In this class, you better document every absence. I usually just say every exam absence, and I don't really care too much about lecture. But for this class, you better document all your absences if you want to. I mean, if it's a medical or religious observance or something like that. So go ahead and do that. So I got tons of letters from rabbis and priests and whatnot saying, excuse this student and stuff. So that's normal. So just go ahead and do that. Now, what I forgot to put in the syllabus, which I normally put, is this. It's just the stack of points that we get in the semester, task by task. Okay, so here's the breakdown. Now, this is also in web courses. I made a special page just for this. It's right below the syllabus handout. So there's the three midterms. So each midterm is going to be 42 points. Now, last spring, we had a shorter class time, so we only had 36 points for each midterm. This one, we're going to have a little bit more time. So it's going to be 42 points, and we're going to keep the best two. So that's 84 points out of 240. Then 36 and 36 homework and classwork. All right, now each of those is smaller than a midterm, but together they're bigger than a midterm. They're also easy to, well, homework might not be easy to get, but classwork will be easy to get. I mean, it's just, basically you're going to be here participating in stuff. So you want to get all those babies, all those points, as many of those as you can. The final is twice the size of a midterm, 84 points. So the proportions are 35% for two midterms, 15% for homework, 15% for classwork, and 35% for the final. So so think about it this way. Homework and classwork together are 30% of your grade, and that's bigger than a single midterm and almost as big as the final. And the reason that I'm doing that is because you're expected to be here every day. All right? And on time. All right. By the way, for those of you that are new here at UCF, if you are, the parking, did you hear about downtown campus? They have 9,000 students down there and only 2,000 parking spots. I said to myself, when I saw that on Channel 9 Eyewitness News, and I thought, oh yeah, that's typical UCF planning. And for those of you that don't live on campus, I don't ever want to see you late because you didn't get a parking spot. Figure it out. Figure out a plan. Don't ever come, especially to an exam. And God forbid, I don't want to see you at 8 o'clock in the morning on December 6th. Oh, I couldn't find a parking spot. Can I take my final? And you're too late. Somebody's already finished and left because you couldn't find a parking spot. You couldn't ride a shuttle bus. All right, so figure it out. Don't do that. Now, hold on. Shh. We're going to have a announcement from Kendra.
Hi guys, I have tutoring hours in the physics help room in the physics building. It's PSB 158, and it's every Wednesday and Friday from 4:30 to 5:30. And that time and time class are the only times I can help you guys. Any other time I can't. So 4:30 to 5:30 both Wednesdays and Fridays if you need me. And it's PSB 158. And a schedule will also be posted outside the classroom. Yes.
Yeah, we'll put it in web courses. Also, my office hours are Wednesdays, 12:30 to 1:30 in room PS 158 as well. And so I'll be there today in case you want to check in and discuss any topic. What about you?
I don't have any scheduled. I can make some up.
All right. Well, Andrew's going to think about maybe making some office hours too. Although I'm not sure if you're allowed to, but we'll talk about it. So now we're ready to talk about electrons and stuff. If you haven't already done so, you should be reading chapter 18. And I have already started to make annotations in chapter 18, section 1. Now I'm going to try to make as many as I can, kind of extra information, emphasis on vocabulary terms, just sometimes just highlighting stuff that's important. And I've already started doing that. Now, my practice in previous semesters was also to point out questions that I like at the end of each subsection. So chapter 18.1, I don't know, I haven't got to the end of it, but it might have some questions and problems. Chapter 18.2, I'll be reading that. And this is my first time through these later chapters. And so we'll be doing that. And I'll point out, I'll highlight and maybe annotate problems that I like. Now, it's up to you what you want to do. But if you want to study the problems that I like, you will find that it will be helpful on exams, because exams are my way of interrogating your mind to detect whether you, as an individual, savvy the things that I consider important. everything that we do in here is going to be covering and discovering and learning about things that I think are important. Nobody can cover every sentence of every page of a textbook. Can't do it. So I have to make an executive decision for every class. Okay, what's important enough to cover today? And then, and part of that is the list of problems that I like, right? So if I point out, oh, this is a question I like, that's a tip, that you want to study that and possibly be ready for it. So we're going to dismiss now. I want you to study up to chapter 18.5 and look for a post about problems that I like from those sections. All right, you're dismissed. I'll see you on Friday. Office hours today at 12:30.